here in, we think, September, hopefully, with a program for science literacy week next year. We're going to take summer off, and I would just want to spend a bit of time finding out about you before I tell you about me and what we are. I shouldn't say me, I'm not going to tell you about me, I'm going to tell you about RCI Science. But my name is Kirsten, I'm the Executive Director of RCI Science, and what I want to know about you is whether or not you have heard of us before. If you have, just let me know. And who's here for the first time? All right, about half and half. That's wonderful. Thank you very much. So we are Canada's oldest public scientific society. We've been around since 1849, and this is our 170th anniversary. Except I was saying to Simon here that we may actually extend that because we didn't get a real official recognition as a royal thing. We're the Royal Canadian Institute. We didn't get that until 1851. So sometimes we celebrate birthdays over 2 years because we like cake a lot. So what we do is we try to connect Canadians with science, all aspects of science. And there are science and things that you might be surprised about. For example, we're actually planning an event for the end of May in Toronto about the science of getting around. What will mobility be like in 2070? So we're going to talk to some people who do transit modeling and all sorts of interesting things. We haven't actually got that all set yet. At the end of April, we'll be doing a discussion on the future of zoos. What do you think? Stay for a poll. Do you think animals still belong in zoos? Do zoos still fulfill a useful function? Who thinks they do?
For like extinction purposes.
Extinction purposes? Okay, I'm collecting that here, so I'm going to talk to the person who's organizing this. Who thinks zoos still fill no useful role in the modern age? Should just let all the tigers out. Yeah? Okay, who's not really sure? Well, if you're interested, come down. I think it's April 28th down at the University of Toronto downtown campus. So,
let the tigers out.
no, we wouldn't want to let the tigers out, although it is Scarborough, so. Yeah.
They might come over here, though, you never know.
We have active programs here in Mississauga, in downtown Toronto, in Ottawa, Waterloo, and we're also looking to start programs in Halifax and Vancouver next year. So we are hopefully going to be a national organization, much like our founders, Sir Sanford Fleming. We have a dream of going across the country. If you don't know, Sir Sanford Fleming helped survey the CPR Railroad. So we are hoping to bring science to all Canadians. We've been 170 years getting this to happen, but hopefully in the next few you'll hear about us more often. So thank you very much for coming out here tonight. I would be remiss in mentioning that we are a membership-based organization, so if you'd like to become a member, you can speak with Carrie, who is out front, or me. Happy to tell you how to do that. It's not hard, doesn't cost much, and you get lots of fun stuff in return. Right, Simon? Yes. All right. So let's just move right on to tonight's talk. We met Eric. Eric, and I forgot to actually ask you officially how to pronounce your last name. So I'm going to say, I'm going to guess, and you can laugh at me if it's wrong. Okay. Is it Ossoluski or is it
That's good.
Ossoluski?
That's great. Ossoluski is good.
Ossoluski. Okay. Eric Ossoluski. We met him in Waterloo actually earlier this year, and he did a talk for us, and it sounded fascinating. So we thought we'd like to work with him again and do something here in Mississauga. Eric's had a very interesting background. I know he's going to weave some of the story through his talk tonight, so I didn't want to mention too much. But he started out in physics, in biophysics, and then ended up now as what he describes as a maverick entrepreneur. And you can see by his laptop that he has a lot of different interests and things. He got interested in big data and visualization. I know you wrote some papers about using gaming in physics education, which I thought was really interesting since I teach physics sometimes, and it's a very interesting thing. But tonight we're going to hear Eric's take on turning that gaming, that VR experience to healthcare. Because that's what I'll tell you, he had a personal experience, a lived experience, which has informed some really interesting ideas about using data in healthcare. And how much, we all know we can get our genome sequenced now. How useful is that? Should we do it? Is it something that we should know? How much data should we have about ourselves? And how can we, as mere mortals, understand all of this and hope to make sense of it? And worse yet, communicate it to our doctors and hope to understand what they're telling us. So I hope that's sort of an accurate summary.
Thank you. Can you hear me all right? Okay. So hello, how do you do? Good evening. Very wonderful introduction. The title of the talk is somewhat confusing. I came up with this talk earlier last year, and sorry, you can't hear me? Yeah, sorry. Please hold while adjusting. Hello. Is that better? Okay. So, hello, how do you do? Good evening. The title of the talk, Software as Medicine, the Meta-Gamification of Everything. Like, what the heck does that mean? I was looking at this title a few days ago in preparation for this talk, and I myself was a little bit confused. So, as we often do in physics, I'm going to start with a few definitions. So this is kind of what my experience looked like before I get into the definition, so you can kind of get a sense of the experience. I had cancer on my tongue. They had to remove 25 lymph nodes. They had to remove an artery. They had to use tissue from my arm to reconstruct part of my tongue. So if you think I say a lot now with half a tongue, imagine how much I said before with an entire tongue. So, and that's kind of a cryptic joke. But as you can see, it looks very intense. And the experience left me not wanting anyone else to go through it. And I was in a unique position because I had worked for a biomedical charity in 2015, the second largest in the world, Wellcome Trust, on visualizing and representing genomics information in virtual reality, because a screen is a little bit too small. Your genome is about 6 billion letters. It's probably the most important spelling test of your life. And in fact, learning about your own healthcare is probably the most important homework of your life. So let's start with the definition. Gamification. This is kind of a new term. Not much consensus exists, but the general idea is that we apply typical concepts of game playing, such as giving people scores or competitions, competitiveness amongst themselves, to promote a certain behavior. And meta refers to a self-referential kind of structure. So you can have physics, and then you can have metaphysics, the physics of physics. So the gamification of gamification in the sense of healthcare. So what I mean by that is, I hope that with this talk you go away with, or you come away with a central message of hope and aspiration, because I hope that I can foster human motivation and performance in regards to improvements in healthcare and quality of life. So my quality of life was affected quite significantly when I was diagnosed originally with cancer, and the process took about 10 months. So throughout the 10 months, I had a frustrating experience, because I spoke to many physicians, 7 over the course of 10 months, who didn't quite know what I was talking about, didn't even believe me that I believed that I had cancer, and I was right in the end, so haha. But there were certain roadblocks. Like when I spoke to some physicians, they said, what's the point of looking at your genome if you don't know what you're looking for? Well, that's where metadata comes in. We can look at the patterns of big data sets, and we can extract information from that and make predictions or understand a little bit more about individuals from large groups. So the process began with like a simple lump on my tongue. I went to a doctor. They told me this was something, not to be concerned with. It was just oral thrush, some sort of yeast infection. But little did I realize that point was going to be a very contentious one, because we have a lot of roadblocks in medicine as patients and physicians. So I'll start talking about it from the perspective of a patient. So I, as a physicist, still had a difficult time speaking to many doctors. And there was this kind of elitism, I would call it, that they didn't really believe that I knew what I was talking about. They either criticized it or downright just said that I was lying or that it wasn't true. And this is something that, all of us can relate to, because whenever you have anything that you're worried about, you go on WebMD and it says everything is cancer, right? So that's kind of a scary thing. Well, maybe the algorithm is a little bit right. Maybe there's something more that we should be considering there, that maybe cancer is multifaceted. It has many different perspectives from which it can emerge, but that's not something to be scared of. The lives we live are mortal ones, and the time we have here is kind of a gift, and we should appreciate it and try to do something, give back perhaps. And so that's what I'm trying to do as a patient myself. But the aspect of using technology to augment my healthcare was something that was very difficult to communicate to physicians. So there was many physicians that either didn't understand the technology, didn't understand computers themselves, didn't program themselves. So in that sense, I understand their aversion, because technology can be scary. Like, there was a recent update to Android, and it's a little bit scary using a new user interface, because you feel a little bit stupid, you feel a little bit confused, and that's a normal process, and you just have to work through it. So future technologies can be scary, but not if we are aware and informed. So if we take a proactive approach, we can all benefit from these things. So we want to manage that complexity. We want to manage our health by extension. One of the main things that you can do with a service like 23andMe is get your raw data and use open source software to look at large databases all over the world. And you can extract information from all of them. So you're not just looking at one database in Cambridge or one in New York. You can look at all of them aggregated together, and they can give you a list. It's like 24,000 maybe entries on a spreadsheet, and it tells you your specific gene, it tells you your variant, and then it gives you a list of all of the publications that come along with that either give supporting evidence or contradictory evidence, and then you can evaluate it yourself. And it's a difficult process, but it's one that we can tackle together. We can look at these issues and work with physicians. So the aspect of communicating with a doctor could be made much easier if we had some sort of technological intermediary. So places like DARPA, the Defense Advanced Research Projects Agency, they're working on technology that resembles computer-assisted human interfaces. So you have a computer almost make predictions about what you want to do. And you could imagine that by extension in the future that looks somewhat like the holodeck, that you just speak the words, kind of like a genie, and they just grant you your wishes. But this requires some training, some learning. I'd spent about 10 years after high school studying physics, and I actually took a break from school in my 4th year because my father passed away, and so I took some time off. And it was an invitation from Wellcome Trust to work on the Big Data VR Challenge that brought me back into this, into the field of academia, into the field of research. And from that, I was able to have almost an advantage when it comes to analyzing or tackling this problem. So you can use something like 23andMe, get the raw data, put it into something called Prometheus, and it looks something like this. So this was a specific example. So the kit is there. There's the 23andMe kit. It's just a little test tube that you spit into, but then it gives you this kind of, gives you a position of your gene, and then it gives you kind of a summary. Mean survival time of 25 months for esophageal squamous cell carcinoma. So I had squamous cell carcinoma on my tongue, very close to my esophagus. And so, the universal lottery said that I only had 25 months to live. My father had passed away from a similar cancer and did not survive his cancer for more than 30 days. He had been suggested to be given radiation therapy after the surgery. I was fortunate enough, because I had this particular information, that I qualified for a clinical trial. The physicians wouldn't have known this in time, because of course the genome sequencing technology is not instantaneous, so it would have taken some time, and perhaps at that point where I was, I didn't have many months to wait. I had very little time. As cancer growth has this kind of sinister approach, it grows exponentially, so that kind of resembles a hockey stick. At a certain point, it just really starts growing, spreading everywhere, and then it metastasizes, meaning it breaks up, spreads through your bloodstream, all out through your body, and that's exactly how my father passed away, as a cauliflower-type creature, which is an unfortunate way to pass away. But I looked at this and I thought, well, why did that happen to him? Part of it had to do with the fact that my family was near the Chernobyl incident, when the Chernobyl power plant had a catastrophic failure. It let off a bunch of radiation that fell down as rain all over Europe. So a lot of people from Europe actually end up developing cancers, and it's the children that actually develop the cancers because there's enough time for the error to build up. So looking at this information, I again consulted my Prometheus database, and I saw, well, there was a study that found that people who had undergone some sort of cancer treatment and they received radiation therapy and they were near Chernobyl had very, very poor outcomes. So with that information, I took that to my surgeons, to my oncologist, to the entire team of doctors, and I convinced them that I wanted to opt out of radiation therapy. So as of a few days ago, it's been a year since my surgery. So in that sense, I kind of beat my dad. He only had 30 days, I have 365, so woohoo me. But that's a testament to the homework, that's a testament to the advancement of the technology. The chemotherapy that I had didn't exist back then. So this was only possible because I worked with researchers who, on the cutting edge of science, and science is a very peculiar thing, because before we get any further, I have to address this, because even scientists mess this up. So science is a method. It actually it follows something called the null hypothesis test from statistics, where you test evidence against a null hypothesis, not for it. So you're never proving your ideas, you're only ever disproving ideas. And that's why the competitive nature of publications in science gives such excellent results, because we're all encouraged to kind of, pardon the phrase, but shit on each other professionally. Kind of, oh, this colleague published this paper, well, I'm going to prove that he doesn't know what he's talking about, or she doesn't know what she's talking about. And this kind of almost hacking of our human nature enables us as a species to benefit a lot. So this amount of big data, you have to really have big data tools. Some of the tools we used were from the military, others were developed by universities, and so it's a worldwide collaborative effort that we all benefit from. A lot of it had to do with Python tools, which before the most recent version of Ubuntu was very much a pain in the butt. Now it's getting a little bit easier. So for anyone who does any sort of scientific research using computing, you can understand how frustrating that can be sometimes. So the question very quickly becomes, how did I use this information? Well, the Big Data VR Challenge introduced me to something called Unreal Engine, which is a video game engine developed originally in Waterloo, Canada, and now it's one of the largest video game engines in the world. It actually powers Fortnite. Fortnite has made $9.4 billion since 2015, just on selling accessories in a multiplayer game where you have 100 players play together until the last team standing sort of thing. But as you can see here a little bit, it's not programming how you remember programming. Programming has become a little bit more visual. A visual scripting kind of programming language allows you to think at a higher level. It allows you to abstract things, and you don't have to take my word for it. Even NASA uses this in their prototyping process, because to optimize it, of course, we need someone to go in and really do the nitty-gritty coding stuff afterwards. But to get the initial prototype, to get the concept out there, especially in an environment like virtual reality, there's nothing better than a visual scripting language. So how big is big data? Well, a human genome is about 6 billion letters, so you fit on a DVD on average, okay? Because it's like the left side of the zipper, right side of the zipper, they come together into a double helix, and some of the letters sometimes are the same, sometimes they differ. So single nucleotide polymorphism mutations mean that the zipper sometimes doesn't match on the left and the right, so we need approximately a DVD. But how much information differs between each of us? About 7 to 20 megabytes is different between each of us. So we can actually quantify these things. But how do we quantify that from the perspective of all of this research? Well, when we look at the problems faced by physicians, one of the main problems they have in communicating to us is comprehension. That our comprehension is lacking, that we don't know, that it's almost meaningless to explain to someone what the particular details of a certain diagnosis mean, because it's not like they're going to understand. Well, I made the joke with Karen that it was in preparation for this talk that I jokingly said, when I go into a doctor's office and they tell me some technical term about the human body or disease, I say, I don't know what that is, can you tell me? And they roll their eyes in a sort of way. The immediate response from me was, well, do you know what quantum electrodynamics is? And of course, Carrie knew. So that was a rare situation, but most physicians wouldn't. So we can all kind of understand that we all know something. Perhaps somebody else knows something. We just need something in the middle, like Siri, to be an intermediary. So when I ask a question and I don't really articulate it properly, maybe the computer can interpolate for me, or it can explain a little bit more simply what a physician means when they say so-and-so. But physicians are encumbered by the onslaught of publications data. So in the medical field alone, there are about 1,000 medical publications released each day. So I read maybe 5 or 10 publications a day. I can't imagine reading 1,000. And so there is no way to keep up with that kind of acceleration of information that we're generating as a species without using technology. So when you go into a doctor's office, they have this problem where, it's the know-it-all patient. They know everything, and there's no point in explaining anything to them. And then doctors are frustrated themselves because there's a few things that are frustrating about medicine, that perhaps sometimes you don't have all the answers. That, most doctors now come into the clinic with a tablet. Why do they come into the clinic with a tablet? Because they're Googling as you're Googling, right? So they're playing catch up just as much as we are. So the next thing that I would say is a little bit frustrating is this idea of procedures and protocols. So procedures and protocols have to be followed because it's kind of a diagnostic way of doing things. We have to do things step by step. We have to do certain things before we do others. You can't just immediately do an MRI because there is a certain limit to how much we can spend in healthcare. So there has to be a way to optimize this. So either you can invent a new sensor, which you can see on the side there. That's part of a project that I'm working on for sequencing human genomes using just radio frequencies. But that's only because I worked with the researchers in England, and then afterwards I worked with some Russian colleagues at the Russian Academy of Sciences, and they found a way to encode human genome data in binary. We can read radio waves with binary signals from the sensor. And then someone by the name of Luc Montagnier, Nobel laureate, discovered that HIV suspended in aqueous solution emitted a certain radio frequency, kind of like a song. So perhaps some of you can invent the future, change the way medicine is done by inventing new technologies. The cost of diagnostics is one of the most limiting factors. For myself, I had a very negative experience because the CAT scan actually made the cancer grow faster. So I had to have a CAT scan before the surgery so the surgeons could know the margins, but that actually accelerated it. And that was one of the side effects that I was concerned with, actual extended radiation therapy. So how could that affect me if I had to go into regular radiation therapy? Perhaps my outcome wouldn't be so good. So in a sense, you can't do an MRI before you do a CAT scan, but maybe we can if we kind of focus on the technology. And in the end, someone like myself, the cost of treating me, which now I feel indebted to all of you, kind of a bonus, but the cost of my chemotherapy was about $18,000 a pill, 2 pills a day for 17 days. So I was like, yes, please sign me up for that clinical trial. So I didn't have to pay for that, and I was sponsored, but again, that's a very fortunate situation. How much did it cost for the surgical team to do the operation? In fact, I had to have an emergency operation just 3 days after my first surgery because of a hematoma, because there was some other issue. So altogether, it was about $2 to $3 million of government funding, public healthcare funding, was used to save my life. Whereas if the physicians had only listened to me within the first month, where a computer algorithm told me to within a high certainty, to 99.9999% chance that I had early cancer. They could have gone in, very minimal surgery, I wouldn't even have to have been put under. It could have just been a very superficial thing, and that would have been the end of it. So we kind of have to understand the challenges that physicians have, but there's also another challenge, this challenge of IT literacy. So you can see there a child is playing, I'm going to say Fortnite, but it's an older image, but that child is probably going to pwn me or kick my butt in a video game because they're so good at it, and it comes naturally to them. Well, there's this kind of, so I would say IT literacy matters because it helps us bridge the divide between science and clinical work. So when we have a situation like a patient, like your healthcare, you're going to use technology, the doctor's going to use technology, maybe we can fix things in the middle a little bit. So, like I said, coding doesn't have to be scary. Here's an example of some of the work that I did, where it's a very visual script. You can kind of see it from left to right. That's a program code. It's just a circuit that you connect, and it runs through and it does something. So perhaps in a clinical setting, that could be something that could be used, a very quick way to prototype a hypothesis. Is this true? Siri, tell me what the probability is that Mr. Johnson or so-and-so, this family, they have this disease. What are the other diseases that they could have? Are there other issues that I'm missing here? So I'll just go back one slide before I go back to that one, but there's also another cryptic kind of statement that's often used, which is that if you're a doctor, and I don't mean to be ageist, but if you're a physician and you're over the age of 45 and you don't do research, you're probably not going to know much about genomics. In fact, your patients will probably know more about genomics than you do, because they're the ones at home Googling about 23andMe, watching these lectures by world professionals like Craig Venter, who's the one who actually said this thing about doctors being over the age of 45 not knowing anything about genomics. That's not me. I'm just repeating what he said. But I agree with that, because if you think about it, there was no Human Genome Project when they were in med school. When they were going through their training as professionals, this information, this knowledge didn't exist. So, so there is this problem that you have to kind of understand what medicine is. It's more of an art, actually. Because if you've ever noticed, when you get a certain medication, they don't say, you know what, stop, just check if what your symptoms, if they go away or not. They don't do that. That would be scientifically rigorous, but of course we don't do that, so in that way medicine is not a science. It uses scientific results, but that doesn't mean it's not useful. It's in fact very useful. But the idea of using data to augment the results of your prognosis, that's something that many of us haven't looked to. I don't know the last time that I looked at my phone and said, oh, this phone is going to save me. Your healthcare is probably the most important homework that you're ever going to do in your life. So, lastly, I'll touch upon, what's the difference between public and private healthcare. I was fortunate enough that my wife, my partner in life and science, Janelle Resch, she had almost a cult-like following from her students, where she teaches math at the University of Waterloo. And a lot of them donated to our GoFundMe thing, our GoFundMe page campaign that sought to allow us to go to La Jolla, San Diego, to Craig Venter's institute called Human Longevity, and do advanced medical diagnostics to examine the information to a level that isn't available here. Jokingly, I said that when I get this information from this institute, then I'm going to bring it back, that we Canadians are going to spy on the Americans. We're going to bring it back over here, and we're going to change healthcare here with what we learned from them. The Americans thought we were joking. Of course, we are not. But they let us have all the information, and of course, I've passed it on to the physicians, but I want to make it accessible to each of us, because the document that I received was a few hundred pages. I don't know the last time that you've had time to read 400 pages of legalese scientific jargon. That's overwhelming. Perhaps there's a way to bridge that gap. So throughout this process, after the Big Data VR Challenge, I assembled a team of kind of, the academic Avengers, if you will, a neuroscientist who does genomics, a physicist and systems design engineer, even English majors and mathematicians, to address this problem, because the bag of tricks that I've collected, I'd like to share with all of you. But you're not going to learn Ubuntu or Python to run the scripts. So I have to make it very visual, very easy to use, because if it's not easy to use, I don't know about you, but I'm pretty lazy about learning difficult things. So I was fortunate enough to have the support from this GoFundMe campaign, but many of us do not. And if I have this much difficulty communicating with physicians myself, then the average person is pretty much, right, bleep, they're pretty much screwed. So we also have to fix that. We have to raise the awareness of the public to this issue that, if there's 1 to 2 doctors per 1,000 people, then maybe we can use technology to make up for those inefficiencies. So lastly, I'm going to promote, and this is me taking the chemotherapy. I did a blog when I was going through the chemotherapy every day because I wanted to give as much data to the scientists as possible. I tried to photograph the tumor every day from many angles, make videos. I even made special filters just all for them so they could just look at it without having to do anything themselves. But a lot of what I learned and came across, I learned from this very wonderful program called White Coat Black Art on CBC Radio. It's hosted by Dr. Brian Goldman, who I follow on Twitter, and he follows me back, woot woot. And I hope that in telling my story on his platform, that I can further this effort, this campaign, to make a difference, so that all of us can benefit, because wasting $3 million saving my life makes me feel in debt, which motivates me to get up and work every day, but we can't do that for everyone. That's a very expensive way to do healthcare, and if we can just catch things a little bit earlier, we can make a bigger difference. Most cancers are caught at stage 4, especially for oral cancer. That's something that, if you don't examine your mouth every day like some sort of crazy person, you might not notice that little lump. And it'll just grow and grow, and all it takes is a few millimeters before it becomes metastasized? One of those words. So I encourage all of you to subscribe to and listen to his program. It's a podcast. You can listen to it while doing the dishes or cleaning your home or whatever, exercising. But he covers a host of topics that perhaps my story, and in general, you can just talk to your families. Make sure you talk to your loved ones. Encourage them to go and get that biopsy. The mistake that I made was trusting 7 general practitioners when I should have just gone to the ER after the first month. This is something that I leave you with that you should do if you have a similar problem. If you have a problem and it doesn't go away within a month, go to the ER, because they'll take a biopsy, they'll do something. Because if you wait a few months, sometimes that's too much. So that's kind of the hopeful message that I think I communicated, that I hope you remember. And I left some references here. I'll make this presentation available on the RCI website. And if you have any questions of any sort, I can try to take a stab at them. Please note, I'm not a medical doctor, but I don't mind helping you find those resources, because it's the access to the information, the access to the knowledge, that's the limiting factor. So, thank you.